So we have covered presentation layer, session layer. Now we discuss about the transport layer. Am I right or no? Session layer.
Session layer.
Session layer. The session layer is responsible for setting up, managing, and then tearing down session between presentation layer entities. This layer also providing dialog control between devices or nodes. It coordinate communication between system and the server to organize their communication by the offering three different mode: simplex mode, half duplex mode, and full duplex. The sum up the session layer basically keep the different application data separate from the application data. So we have discussed what is the simple.
Simplex, half duplex, and full duplex. I know about it.
Okay, simplex mean when we
When
sender send the
only one
message
way,
but respond don't respond, and half duplex means
one way can
the
be done.
first sender send the request, then
Then
after
sender.
that
Send,
the responder respond. And full duplex means the same time bot discuss
both can discuss.
each other. Okay, so when we open any site, then from my PC to this google.com communicate each other, and here session communicate between source to destination. Now talk about transport layer. The transport layer segment and reassemble data into a data stream service located in the transport layer. Transport layer segment and reassemble data from upper layer application unit into the same data stream. They provide end-to-end data transport services and can establish a logical communication between the sending host and destination host on internetwork. Some of you probably familiar with the TCP and UDP already, but if you do not no worries. I will tell you all about these in chapter 3. If so, you know that both work at the transport layer and that TCP is reliable services and UDP is not. This means that application developer have more options because they have a choice between the two protocol when working with the TCP IP protocol. So you know the TCP is reliable communication and UDP is unreliable communication. TCP is
Cross.
slow communication and UDP is
Fast but not secure.
but not secure. The transport layer is responsible providing mechanism for multiplexing upper layer application, establishing session, the tearing down virtual circuit. It is also hidden details of any network dependent information from their higher layer by the providing transport data. Now transport layer network. These are all the part of the uh, TCP, application transport internet and link. TCP UDP, two types. These are all the protocols. DNS also protocol, but it is a part of the application. Domain name service, RTP. RTP generally we are using for the voice. SMTP, simple mail transfer protocol, when we are using the mail. And HTTP is
For browser.
for browser, and HTTPS also for browser. And internet have the two. IP means you internet protocol, and ICMP means when we ping. So ping is working on the ICMP. When we ping, then ping is the ICMP. 8.8.8, 8.8.8. And what is the full form ICMP? ICMP full form. Internet Control Message Protocol. This is the
ICMP.
so here multiple ping send, ping receive. So different when we work on the firewall, then it is discussed in the in detail. Okay, so transport layer. These are the 7 layer application sessions, presentation session, and this is the transport. Transport is a network and transport. Okay, and here's the good example of transport application data, transport network data. Telnet, TCP, UDP, IP, data link, physical. So you see here, the Telnet is working on 23 port,
Hmm.
and Telnet client, this is the customized port 51001. Application layer, application. Transport layer either working on the TCP or UDP, and this is the IP. This is layer 3, this is layer 4, and this is layer 7.
Okay.
Application layer, SMTP, transport layer, TCP, SMTP, message, IP, data link. So Ethernet. Okay, now back to the any question query about the transport layer. So when any traffic, so this is the data. Okay, so this is the data. When data going to the another side, then IP header here put into this payload data, and after that it's work on the TCP or UDP too. So it's connected, it's also connected with TCP header. TCP header. Okay, so TCP header on different port, HTTP, STTP, or 23 or telnets, many ports in the network. So actual data is here, but when we communicate with IP and TCP, after that it's all three applications upper layer communicate, then this is the complete packet. This is the payload, yani ki your real data, after that IP, TCP, then session, application or presentation. Okay, now flow control. The transport layer can be connectionless or connection oriented. Connectionless means UDP and connection oriented means TCP. However, Cisco is mostly connected with you understanding the connection oriented protocol of the transport layer. The following section will provide the skinny on the connection oriented reliable protocol on the transport layer. Flow control. Data integrity is ensured at a transport layer by maintaining flow control and by allowing applications to request reliable data transport between systems. Flow control prevents a sending host on one side of connection from overflowing the buffer in the receiving host. An event that result is a lost data, reliable data transport employ connection-oriented communication session between system and the protocols involving ensure that the flowing will be achieved. The segment deliver are acknowledged back to the sender upon their reception. Any segment not acknowledged and retransmitted. Segments are sequenced back into their proper order upon arrival at the destination. A manageable data flow is maintained in order to avoid congestion, overhaul, overloading, any data loss. So what is the segmentation? Is small chunks,
What is
छोटे
small
छोटे
chunks?
पार्ट में जाते हैं, छोटे छोटे पार्ट में जाते हैं. अगर मैं सेगमेंटेशन देखूंगा गूगल, where is the segment? Network segment is a network security technique that divide a network into a smaller distinct sub network. छोटे छोटे पार्ट में जाएगा आपका, एक बड़ा बड़ा सा पैकेट होगा, वो छोटे छोटे उसमें जाएगा सिक्योरिटी पर्पज से.
अच्छा,
नेटवर्क सेगमेंटेशन, सर्विसेज 1 and 2, सर्विसेज 2 and 3, नेटवर्क सेगमेंट 1, नेटवर्क सेगमेंट 2, सर्विसेज कस्टम डेटाबेस एप्लीकेशन. Okay, now back to the book. Connection oriented communication. In reliable transport operation, a device that want to transmit set up a connection oriented communication session with a remote device by creating a session. The transmitting device first establishes a connection oriented session with its peer system, which is called a call setup or a three-way handshake. Data is then transferred when the transfer is finished. A call termination takes place to tear down the virtual circuit. So here this is the establishing a connection oriented session. This is the three-way handshake. This is the sender and this is the receiver. First, sender send a packet like a hello, synchronize package. Then receiver synchronize and acknowledge. Then sender acknowledge. This is the way of the three-way handshake. Connection established. Data transfer. So when three-way handshake complete, and three-way handshake only, it means this is the TCP, reliable connection. Because when synchronized packet send, then synchronized acknowledge packet receive, then acknowledge packet. So this is very important in the network. So when we are working on the network data, then we required 7 layer. How 7 layer work? And when we work on the firewall, then we have TCP 6 flag. So that we will discuss in later. 6 flags, TCP 6 flags. So these all are the part of the data. So these are the, you see, urgent pointer, acknowledge, push, reset, synchronize, and finish. These are part of the TCP header. So we will discuss this later. This is deeply. So like this is the packet, and packet has 16 byte in source and 16 byte in destination. And here this 1 byte urgent pointer, acknowledge, post, reset, synchronize, and finish. So these all six, 1 byte, 1 byte, 1 byte, 1 byte. So these part of the source flag, TCP flags. Okay, now back to the book. So this is now a despite a typical reliable session taking place between sending and receiving system. Looking at it, you can see that both host application program being by the notifying their individual operating system that a connection is about to be initiated. The two operating system communicating by sending message over the network, confirming that the transfer is approved and that both sides are ready for it to take place. After all of these required synchronization takes place, a connection is fully established, and the data transfer being the virtual circuit setup is called overhead. While the information is being transferred between hosts, the two machines periodically check with each other, communicating through their protocol software to ensure that all is going well and that the data is being received properly. When we communicate via TCP, then this is the checksum. It's data deliver or not, and we receive the proof of delivery or not. Like it. So here is a summary of the step in the connection oriented session. The three-way handshake in picture in 1.9. This is the 1.9. Now the first agreement segment is request for synchronization between sender and receiver. The next segment acknowledges the request and establish connection parameter, the rule between host. You know what is the meaning of hosts? Host means
Receiver and
so source is also host and receiver is also
हाँ
host.
sender receiver हाँ.
Okay. Now uh, the receiving segment is here is a well, so we bidirectional connection is formed. The final segment is also an acknowledgement is notify the destination host that the connection agreement has been accepted and that the actual connection has been established. Data transfer can now begin. When three-way entered successfully, then data transfer can start. So sound pretty simple, but things don't always flow the smoothly. Something during a transfer connection can occur because a high speed computer is generating data traffic a lot faster than the network can handle. Transferring a bunch of computer simultaneously sending datagram through a single gateway or destination can be both things up nicely. In a letter can gateway or destination can become congested even though no single source caused the problem. In either case, the problem is basically akin to freeway bottleneck, too much traffic for too small a capacity. It is not usually one car that the problem. There are simply too many cars on the freeway. Okay, so what happened? When a machine receives a flood of datagrams too quickly for it to process, it stores them in memory section called a buffer. You know what is the buffer? Buffer.
Slowness.
So, so data we receive in buffer when traffic
Loading time.
loading. Yeah, flood of the datagram too quickly for the process. Stored in his memory section called a buffer. But this buffering action can solve the problem only if the datagram are part of the smaller burst. छोटे छोटे सेगमेंटों में जाता है smaller burst. If not, and the datagram deluge continue a device, a memory will eventually be exhausted, its flood capacity will be exceeded, and it will react by discarding any additional datagram that arrive. No huge warning here. Though, because of the transfer function, network flood control system really work quite well. Instead of during data and allowing data to be lost, the transport can issue is not ready indicated to the sender or source on of the flood. In SODA 1.10, this machine work is kind of like the stoplight signaling the sending device to stop transmitting segment traffic to its overwhelming peer. After the peer receive processes the segment already in the memory reservoir, its buffer. It send out a ready transport indicator. When the machine waiting to transmit the rest of the datagram receiving this go indicator to resume the transmission. Transmitting segment the flow control. This is sender. Sender send the traffic 1 2 3. Then receiver reply buffer full, not ready to stop. Segment process, then again send. कभी कभी हम बार बार ट्रैफिक भेजते हैं ना जब उसको नहीं मिलता, फिर उसको रिसीव, गो, देन ट्रांसमिट. In fundamental reliable connection oriented data transfer, datagram or delivered to the receiving host is exactly the same sequence. They have been transmitted and the transmission failed. If this order is breached, if any data segment are lost, duplicate or damaged along the way, a failure will occur. This problem is solved by the having the receiving host acknowledgement that is has received each and every data segment. A service is considered connection oriented if it has the following characteristic. A virtual circuit is set up three-way handshake. A use sequencing, a use acknowledgement, and a use flow control. Windowing. Ideally, data throughput happen quickly and efficiency, and as you can imagine, it would be the slow if the transmitting machine had to wait an acknowledgement after sending each segment. But because there is time available after the sender transmit the data segment and before it finish processing is acknowledgement from the receiving machine, the sender use the breakup and opportunity to transmit more data. The quantity of data segment that the transmitting machine is allowing to send without receiving an acknowledgement for them is called a windows. वहां पर reliable data जा रहा था, यहाँ पर the transmitting machine is allowed to send without receiving an acknowledgement for them is called a window. So the size of the window control how much information is transferred from one end of the other, while some protocol quantity information by observing is number of the packet TCP measured by the connecting the number of byte. किसी पैकेट का साइज क्या होगा ये हम डिसाइड करते थे,
रिसीव क्या कर पाएंगे वो
क्या,
होगा।
तो विंडो का फंक्शन है कि डेटा है ना, इसको क्या बोलते हैं, पैकेट, पैकेट साइज इन विंडो. देखो ये क्या है, MTU मैक्सिमम ट्रांसमिट यूनिट, आपको दिख रहा है 1518 1518 एंड हियर इज द 15500. देखो छोटे उसमें जाता है, ओरिजिनल MTU 1500 और न्यू MTU साइज 1518. NetSec interface IP version 4 sub interface. How to change MTU size in Windows 10? So you can change packet size from your window. NetSec interface IP version sub interface Ethernet MTU 1518 store persist. मैक्सिमम ट्रांसमिट यानी कि मैक्सिमम डेटा क्या होगा, कितने बाइट का होगा, बिट एंड बाइट आप आगे चैप्टर में
तो
पढ़ोगे.
हम चेंज कैसे कर सकते हैं? कोई भी डेटा जब हमारे पास में आएगा तो हम उसे चेंज उसका साइज कैसे ऊपर नीचे कर सकते हैं?
एक डेटा है ना, सामने से एक पानी की बोतल दी, अब पानी की बोतल आप 1 लीटर की बोतल में लो या आप आधी आधी लीटर की बोतल में लो, तो आपके ऊपर है ना, आप डेटा कैसे ले रहे हो.
लेकिन हम उसी जो डेटा है उसे ही तो हम ब्रेक कर सकते हैं। ऐसा थोड़ी ना है कि अगर 1 लीटर की बोतल है तो हम 5 लीटर की 1-1 लीटर की 5 ले लें।
नहीं नहीं, देखो सेगमेंट में डेटा चलता है ना, आई एम सो ये लाइक दिस इज द सोर्स एंड दिस इज द डेस्टिनेशन, दिस इज द डेस्टिनेशन, ठीक है. अब ये हमारा पाइप हो गया, दिस इज द पाइप, या हमने MTU MTU लगा दिया तुम्हारा 1500, राइट। इस इंटरफेस में मेरा 1500 का लगा हुआ है MTU, और मेरा डेटा कितना जाएगा, इतना। इतना डेटा मेरा जाएगा। तो ये जो सेगमेंट होगा, ये 1500 यूनिट के छोटे छोटे पैकेट बनाएगा।
1500 यूनिट के ही बना सकता है ना?
नहीं, डिपेंड करता है कि 1518 का कर दूं मैं, 20 का कर दूं।
ये समझ नहीं आ रहा मेरे को।
हाँ, ये पैकेट की साइज है। पैकेट का साइज क्या होगा? तो जनरली क्या होता है, जब सोर्स और डेस्टिनेशन के बीच में वैन डेटा डेटा communicate between source and destination, then this side is a 1500 MTU, then here is also should be 1500 unit।
हाँ, सेम ही तो होगा।
सेम
कम ज्यादा
सेम
कैसे
होता
करेंगे
है,
हम?
बट
वो हम ब्रेक कर सकते हैं, लेकिन
बट बहुत सी बार क्या होता है, इफ here 1500 and here you 45, 1445, then it's also work. But sometime it's not working, then the packets MTU side should be same on the bot side. So how to change the MTU from your machine? Then you net state interface IP version 4 sub interface. Net state interface IP version 4, so sub interface. Net says not recognized as the internal or external command overall program batch file. Okay. देखो मैं यूजर में हूं ना, एग्जिट करो यहाँ पर। मुझे पता नहीं कैसे जाते, जब हम इसके अंदर जाएंगे ना, सी ड्राइव विंडोज एंड सिस्टम 32, देन वी चेक द और चेंज द size. As of now I am the user in Susil, you see. So when we go to the C drive Windows and system 32, then we check this. So this can be handled by the server team or window team or desktop team. Open a command prompt administrator, hit Windows
and
start
it can be
button.
done through ICMD.
You see, hit Windows start button, type CMD, right click on the command prompt and run as a administrator. When you are CMDB run as a CMD run as a administrator. Yes. Now you see 32. Now NAT interface interface IP version 4, so sub interface. You see in my PC all 15 and 1500 bytes. You see, if you want, then you just change here this command net set interface I version 4 set sub interface ethernet MTU 1518. If you want, you change anything 1500, 18, or 1600, 700, all depend on your requirement. You see, now I'm going to the exit, okay, and go to the your book. So this is the book. As you can see, the 1.11, there are two window size, one set to 1 and one set to 3. Okay, 1.11. 1.11 is send 1, receive 1, acknowledge 2, and send 2, receive 2, acknowledge 3. Window size of 3. So first we read here. There are two window size, okay, and when you configure a window size of 1, like 1500, then sending machine wait for an acknowledgement for each data segment. It is transmit before transmit another. If you configure a window size 3, it allow to transmit 3 data segment before an acknowledgement is receiving. It is simply example, both the sending and receiving machine are workstation. It's really, this is not done in simply number, but in the amount of bytes can be sent. The plus point is, if a receiving host fail to receive all the byte that it should acknowledge, the host can improve the communication session by decreasing the side window. Okay, windowing, these the example. Window size 3, send, acknowledge and acknowledge. Now we reliable data deliver ensure the integrity of the stream of data sent from one machine to the other through a fully functional data link. It is generated that the data will not be duplicate or lost. This is achieved through something called positive acknowledgement with retransmission. Positive acknowledgement with retransmission. Are you getting my point? No. इसने डेटा को भेजा, एक बार में नहीं पहुंचा, फिर दोबारा भेजा, फिर दोबारा भेजा, सेंड 1, सेंड 2, सेंड 3, फिर एक्नॉलेजमेंट मिला, फिर सेंड डेटा 4. जब तक उसको सामने से एक्नॉलेजमेंट नहीं मिलेगी तब तक वो डेटा फेंकता रहेगा ना, क्योंकि टीसीपी कनेक्शन है. A technique that requires a receiving machine to communicate with the transmitting source by sending an acknowledgement message back to the sender. Source by sending an acknowledgement message back to the sender when it received data. The sender documents each segment measure in bytes. In then sends and wait for his acknowledgement before sending the next segment round by bytes. When it sends a segment, the transmitter machine start a timer and retransmit. If it expire before acknowledgement, it return from the receiving data. Figure 1.12. The sending machine transmit segment 1, 2, and 3. The receiving node acknowledge. Transport layer reliable delivery. Sender and receiver. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Send 1, send 2, send 3. Acknowledge 4. Send 4, send 5, send 6. Connection lost. 5 का connection lost हुआ है. Acknowledge 5. Send again 5. Then acknowledge 7.
एक्नॉलेज 7 क्यों हुआ? एक्नॉलेज 5 6 होगा ना, 5 होगा. 5 तो हो गया.
1, 2, 3 का इसने एक्नॉलेज किया 4. 4 को 4, 5, 6 भेजा तो इसमें एक्नॉलेज किया 5. 5 को अगेन भेजा तो उसका एक्नॉलेज दिया 7.
7 कैसे हुआ?
मैंने एक पैकेट, मैंने बोला आलोक आलोक आलोक, उसने बोला हाँ भाई सुनना हो। फिर मैंने दोबारा दोबारा पूछा, खाना खा लिया, खाना खा लिया, खाना खा लिया, बीच में भूल गए। तो इसका रिप्लाई दिया कि हाँ खा लिया है। तो फिर मैंने दोबारा भेजी, क्या खा लिया आपने? कि हाँ जी खा लिया है।
अरे वो तो समझ गया, लेकिन एक्नॉलेज 7 क्यों हुआ? वो फिर 6 होता।
6 तो यहाँ भेज दिया है ना पैकेट,
अच्छा 6 भेज दिया इसलिए, ओके ओके।
4 5 6
ठीक है।
भेजा है ना।
अच्छा एक्नॉलेज सेम नहीं हो सकता कोई भी।
हाँ, और 5 इसने सुना नहीं, इसलिए 5 का एक्नॉलेज आया ये,
हाँ हाँ ठीक है ठीक
क्योंकि 5 सुना नहीं ना इसने।
है। हाँ आई
ओके,
गॉट इट।
नाउ लेट्स क्लियर द सेंडिंग मशीन ट्रांसमिट सेगमेंट 1 2 and 3, 3 पैकेट भेजे उसने सेगमेंट। The receiving node acknowledge it has received them by requesting segment 4. Okay. When it receives the acknowledgement, the sender transmits segment 4, 5, and 6. If segment 5 does not make it to the destination, the receiving node acknowledges then even with the request for the segment to be sent. Segment to be resent. The sending machine will then resend the lost segment and wait for the acknowledgement, which is must receive in order to move on to the transmission of segment 7.
ओके।
Now the network layer. The network layer also called as layer 3. Manage device addressing, track the location of devices on the network and determine the best way to the move data, which means that the network layer must transport traffic between devices that are not locally attached. Router layer 3 device are specified at the network layer and providing the routing services with an internetwork. Transport rail reliable. So these are the reliable. Now you see the router is a layer 3 device. You see routers layer 3 devices are the specific network layer in the. So one need to be discussed here before we go ahead. So the layer 1 device, sorry, layer 1 device hub is a layer 1 device because hub nothing doing, just provide the connection between two or more hosts. And second one is switch can work on the layer 2 because switch work on the mac address or some different VLAN virtualization lag, but not L3 interface. Exception is there, but sometime L2 switch as well as L3 switch. So L3 switch have the ability of the router. Then this that is the layer 3. So this is the layer 1 and this is the layer 2. And now router. Router is a layer 3 device because router can communicate between two and more network without any forcefully, because this is the function of the router. And now for layer 4 devices
स्विच
firewall,
फायरवॉल ठीक है।
because
Switch is second.
here the layer 1 on the physical layer, like a wire, fiber cable, connector, all of the part of the layer 1. Layer 1 means layer 1 means you see
एप्लीकेशन फिजिकल।
physical layer is a layer 1 device, like a wire, anything is a layer 1. And data link it means mac address and virtual LAN is a part of the virtual LAN means switch, because here is no IP address, only work on the via MAC address. So this is a layer 2 device switch. And now is the router. can communicate between two and more network. Here is a one IP address 192 series, and here is a 10.1x series. Then automatically communicate two or more network. This is a router function. So here you see the network layer. After that, the transport layer.
Is the fourth one.
The fourth one means firewall, because firewall work on the IP address with the port, service port, like HTTP and
SMTP.
23 SMTP, many more. If you see here, what is the rule of the firewall rules? How to apply firewall rules? How to apply firewalls rules on the firewall. Then here source destination port and services. If you see here, just I show you source destination and firewalls rule. You see here, this is the source, any source here, any destination, services, any, and layer network.
Hmm.
So this is not very clear. I'm going to first act, then go into the Google. Okay, Google. Then now you see here, the source is this one. This IP address is source, and destination is any, and destination port 3389, and service TCP.
Secured one.
So protocol is a TCP, and the service is 3389,
Hmm.
and destination IP address is any. So the layer 4 required one extra, like a TCP connection or UDP connection, or 3389. 3389 is a port for remote access. When we get remote from any other machine, then we require the 3389 port open on the firewall. Okay, like when we permit source this one, destination any, source port any, protocol TCP, and destination port any.
Hmm.
So the lower layer, four part. You see, layer 1, layer 2, layer 3, layer 4.
Hmm.
So these, after that, the session layer, presentation or application layer, that is only how to present your data. But this is your real data in bit and byte. Here the MAC address header, then IP header, then TCP, UDP transport layer, then session. After that, application, present, and application work on the browser or any platform. Okay, so now we go to our here packet size MTU 7 layer. Okay. Now so router is a layer 3 device. Are specific as a network layer and provide the routing services within an internet network. Now it's happen like the first, when a packet is received on a router interface, the destination IP address is checked. जब मुझे बाहर से कोई डेटा मिलता है, this is the internet world. This is the internet world, and this is one user. This is one user, and this is our environment, and this is our server. Okay, this is our server, and here one router. Okay, so router connected with this
Network.
network. When this person want to communicate, then router need to check the destination. It's happen first, when a packet is received on a router interface, the destination IP address is checked. जिसको वो मांग रहा है वो है हमारे पास में. If the packet is not destination for the particular router, it will look up the destination network address in the routing table. फिर क्या है कि ये routing table में देखता है, इसके पास routing table है. Like multiple server we have in the environment, then it's have a routing table, 10 series, 172 series, different. Then it's checking by in the routing table that server we have or not. Check in the routing table. I will show you how to check the routing table. Like a routing table on the router. You see, this is the routing table. Any router 10/24, 10/02/24. So this is the routing table in the router. Okay, later I will show you on the real router. Now where we, so it's checking the routing table on destination. And now, so first, when a packet is received on the router interface, the destination IP address check. If the packet is not destined for the particular router, it will look up the destination network address in the routing table. Once the router chooses an exit interface, the packet will be sent to the interface to frame and send out the local network. If the router can't find an entry for the packet destination network in the routing table, the route drop the packet. Suppose this is one router and here another router, and after that another router, after that this is the host. So इसने बोला कि मुझे 10.1.1.1 पर जाना है, बट यहाँ पर नहीं है, here is no. देन यहाँ पर एक राउटिंग पड़ा है कि 1 डॉट के लिए इस पर राउटर पर चले जाओ और इसके लिए इस बोले इस राउटर पर चले जाओ, क्योंकि many protocol BGP, OSPF and other routing protocol show you how we receive the this PC into the routing table. तो ये राउटिंग टेबल पे चला जाएगा और ये रीच कर जाएगा. If no this data into the routing table, then packet drop.
Packet will drop.
Okay, so now the router drop the packet. Two type of packet are used in network layer: data and route updates. Data packet used to transport user data through the network. Protocol used to support data traffic are called routed protocols. Two types of routed protocols. Example of the routed protocol is IP and IP version 4. You will learn about IP addressing in chapter 3 and 4 and IP version 6 chapter 15. And route updates packet used to update neighboring router about the network connection to all router within the internet network. Protocols that send route update packet are called routing protocols. Example of some common ones are RIP version 2, EIGRP, OSPF route updates packet are used to help build and maintain routing table on each router. So these are the protocol we will discuss deeply, because the OSPF and BGP and uh, other protocol we have required. Internally we are using OSPF and externally we are using BGP. So these protocols are very much required in any network. So show an example of routing table. The routing table used to router include the following information: network address, protocol specific network address. A router must maintain a routing table for individual routed protocol, because each routed protocol keep track of a network with a different addressing scheme: IP version 6, IPv6 an example. So think of it as street sign in each of the destination language spoken by the residents are living on the particular street. सपोज करो ये राउटर है और इस पर यहाँ पर 4 इंटरफेस लगे हुए हैं. 10 सेलेक्ट्स के लिए इधर जाना है आपको, 172 के लिए आपको इधर जाना है और 192 के लिए इधर जाना है. तो साइन बोर्ड like its address, when anyone want to communicate with this router, then its route, and if wants some other than this route, so this is work as a signboard. If there were American, Spanish and French folk on a street named cat, sign would read cat, gato and chat. Interface: the exit interface packet will take when des- destined for a specific network. मैट्रिक्स, मैट्रिक्स बिल्ड भी आपको बताऊंगा क्या है मैट्रिक्स बिल्ड.